So first of all, hello everyone, and welcome on the last session for today. I'll be covering Oracle OpenStack 3.0 version and how to deploy Oracle Database 12c in 30 minutes on powerful systems, or in my case, in virtualized environments, like 45 minutes or more. My name is Lucian Preoteasa. I'm a principal technical sales consultant for Oracle Linux and Oracle VM, so I represent these two products. And I'm going to showcase what our flavor of OpenStack delivers for performance. And also, I have like a small recording on a deployment example of Oracle database using our flavor of OpenStack. The 3.0 version doesn't mean that we are very old in the general mainline OpenStack versions. It's based on Mitaka, so we are 1 to, let's say, versions older than the official OpenStack mainline version. As always with Oracle, the safe harbor statement, it's mandatory it's an NDA statement basically, so whenever we have external audience, we have to show this slide. So I'll be a bit brief. We'll first begin with the OpenStack differentiation factors. As Dan presented, one of the best way to deploy and use OpenStack is through Docker containers and Cola, and our flavor has the exact same features. So we consider, we have evaluated in initial version 1, we have used PackStack, and then we progressed version 2 and versions 3 are using Docker containers. So all of the OpenStack services are being containerized inside Docker containers, and we use Cola to do the deployment. And then we'll talk about some software releases, some versions, and then I'll showcase, I have some slides with the steps necessary to do the Oracle Database 12c deployment. And after that, I have also a small recording. I compressed it to 9 minutes just to see the entire steps. I'll log in, I'll SSH on the instance, and you'll see inside the process of installing Oracle database. So as every OpenStack flavors, ours is it's a management framework. Basically, it's enterprise ready, connects with Oracle Public Cloud, but also with other public cloud solutions, and basically it helps customers to create virtual data centers. Our flavor basically comes from the second, let's say, largest software vendor overall, and it comes with an integration with Oracle Linux and Oracle VM, first of all. And this means Oracle Linux, it's an RPM-based Linux distribution that uses the same source code as Red Hat does. So you're kind of a CentOS. And although we are Oracle, I represent Oracle, both Oracle Linux and Oracle VM are completely open source. You have fully access, free to use, free to download, to distribute both products. We have an edelivery.oracle.com website from where you can download the so you can download some images that we will use in this process, and also you can even download our OpenStack flavor and use it. Oracle VM, it's our Zen-based hypervisor, so we have decided to go with Zen because it's one of the most used hypervisors in the public sector, in the public cloud. And besides this, our flavor of OpenStack comes with MySQL cluster, active-active, and comes with Oracle's heritage of products overall. We use Docker containers, so as Dan presented before, we have the same way of deploying it, which makes much more easier, not only the deployment, but especially the upgrade process, simplifies it a lot. And unique features, we have, let's say, a more robust OpenStack flavor by the fact that we have redundancy at the database level for Nova, for Glance, and we use the MySQL cluster active-active. And a unique feature with Oracle, it's our K-Splice or zero downtime patch updates. Basically, you can update the kernel and 2 user spaces, OpenSSL and glibc, without the need to reboot the operating system. It's a live, basically, patching mechanism that it's included in our just support contract. It's not fully, it's not open source, this part. This is our architecture, looks like, so exactly as Dan presented. We have containers, we have Docker containers, and there are 3 different possibilities to do an update or a deployment. First of all, you can use local registry, so you can have full control of your Docker images. You have a dedicated local Docker registry. You import the images that are freely available on edelivery.oracle.com, and then you use these images for your deployment. Secondly, for paying customers, there is a private called Oracle Cluster Registry, and publicly we publish them in Docker Hub. They are available. I'm going to show you the website from where you can download them, and you can have access directly to them. Secondly, we need the Cola CLI, and you can download that from the free of charge again from yum.oracle.com. And that it's necessary to create the deployment. Through the help of Cola, you're setting up credentials, you're setting up the host, which will have a role in this OpenStack environment. You're setting up the network configurations. Some specific roles will be playing just the control node. Some other will be just a network or storage or multiple roles together. And there will be just one management node. That is the role which hosts the Cola packages, the Cola CLI packages used for the deployment. We're talking about to have, it's important to have a database, good database solution inside OpenStack to have a redundant environment, because if the database goes down, basically your entire cloud goes down. And especially Nova and Glance database are most important. And here is a comparison between our MySQL cluster high availability solution and the traditional third-party database high availability from Galera. And as you can see, our flavor comes with load balancing and other additional features. So performance and scalability-wise, our version has an, let's say, an upper edge against competitors. Now, regarding software releases, we started in 2014. Our 1.0 version was based on Icehouse, had just the generic services, so just Neutron, Nova, Cinder, and we used Packstat for that deployment. Then we continued in 2015 with version 2.0, which was based on Kilo, and we additionally added Heat, Murano. We introduced the MySQL cluster active, and Ceilometer as well. Also, importantly, we started to containerize our OpenStack services to run inside Docker. Version 3 comes with Mitaka flavors, and they also come, our version 3 comes with AODH alarm service for Ceilometer, distributed virtual routing, Ceph storage for ephemeral instance, and also from hypervisor's point of view, it supports KVM running on Oracle Linux and Oracle VM Servers 3.4, which runs the Zen 4.4 in the background. Also, some integration with Oracle's like ZFS storage appliance, flash storage. These are typically Oracle storage. So we not only have databases, application, hypervisor, operating system, we also have hardware and storage. So we offer dedicated server solutions and flash storage. Now, the main focus for the presentation was for the easy deployment of Oracle database with Oracle OpenStack. So we are using Murano in this case. Murano is basically an application catalog that helps simplify the deployment process, and basically an end user can just press a single click and a complex deployment like Oracle database will be happening in the background. In what's happening there are multiple services, like for example, we have a Murano API who is being used by a client or the Murano dashboard, and Murano engine integrates with Heat. Heat after that is in contact with Cinder to create volumes, with Nova to start instances, with Neutron to ensure network connectivity, and the Murano agent, it's used to basically manipulate the instance inside, and there is a specific script here that is running build cluster.sh, and this script is copied by the Murano agent inside the instance, and this will run in order to create the Oracle database process. Now, there are multiple advantages why we use Murano and now not other OpenStack services. There are some similar ones like this, but first of all, it lets us decouple the versions. So whenever there is a change in Oracle databases, we can use Murano, and for example, if there is a specific patch in Oracle database, we'll import the new image inside, and we can still use with the same version of OpenStack. So we don't have to wait for the next release of OpenStack to have a change in this database. Now, OpenStack uses this flavor. Will use Oracle VM Servers 3.4. KVM, it's not certified to run Oracle products. Cinder has to be used for the with regular and not in ephemeral mode. That's only to be used in dev test environments. To use BTRFS as driver, the storage engine instead of LVM for production environments. And regarding configuration, you will need an Oracle Linux 7.2, which you can download from our eDelivery website, an Oracle Database 12c image, also available from the Oracle website. Now, on this image, on the operating system, we will be installing Murano agent that is being used to copy the necessary files in order to create the deployment mechanism. And we also installed the Oracle RDBMS pre-install package. It's an RPM that automates, let's say, the creation of Oracle database by, for example, installing prerequisites before an Oracle database installation, also setting up kernel parameters and optimizing it before an Oracle database installation. Then the script will run. We will import the images with Glance. Then the script will run inside the instance. We will see all of this in my recording. And DNS for external resolution, and a key pair has to be generated from OpenStack, and I will use that SSH using the key from OpenStack and access the instance, and from the instance we can see the entire process of installation. Here are some slides that I did with the process, and then I have a recording as well. So main important things is we have two images, one for operating system, one for the database. Those I have, and on the one with Linux, I have added the Murano agent. I've installed on it, and also the Murano agent and the Oracle RDBMS packages necessary for the database. Then I will go on the Murano part, as you can see here. Yep, this is part. We have a dedicated service called Murano, and we press here quick deployment. Then we will specify which one is the Linux image, which one is the database image. Everything is very simplified. That's the idea. Otherwise, you could simply just manually do all these steps inside the instance. You simply specify all these prerequisites. You specify a swap disk, a key pair. Then you specify a database name. There are some defaults like ORCL and the default listening port like 1521. Can you see also in the back? I think it's the font, it's a bit smaller. Yeah. So there are some defaults here like database name SID, and you will specify the credentials for sys, for the database user, and for the operating system user. So we use Cloud Init, as also Alessandro presented before, for this deployment. Then the status will change to deploying on the Murano engine. In the background, Heat is being used. So the Murano agent, if you remember in the architecture, it's being used by Heat. Heat is the orchestration part, and Heat after that, you will see here, creates a specific stack. And you will be seeing, for example, the three disks that we were talked about. So one is the operating system, one is the database, and one is the swap. Here are these three. We have two VNICs. One is for internal use, one is for the external connectivity by using a floating IP address. And some other elements here in the stack as well. Here you can see the volumes being created, those 3 volumes, and are being attached to a Murano instance that has been automatically deployed. And when we go to instance, we will see generated name, Murano, and then a specific code. And at the end, you will see the deployment has been completed. I'll go and show you the video with the recording. Second. Yeah, I think now it's visible. So as an idea, we just logged in on the Murano catalog. We press quick deploy. We will specify an application name. In this case, it's an Oracle database. Then we'll press next. We'll select the Linux image. All these, the Linux image and the Oracle database image, before the import, we had specified a specific Murano flag, just for Murano to identify that this image is capable to be used by Murano. So there is a specific, when import with glance, there are specific parameters that you have to insert. Then you put some disk sizes, for example, 50 gigs, it's necessary for the Oracle database, 20 gigs for the operating system itself, and I've put 10 gigs for the ephemeral storage. I already created a key pair, an SSH key pair, which I'll be using afterwards to SSH from the control nodes to the instance itself. I'm using some default, so default database name, you can of course edit that and it will reflect itself in the deployment process. And specifying credentials for sys and for the cloud user, which I will be using with the SSH key. Now this process has stopped and Hit will be used in this case. Hit will be talking with Cinder, will be engaging Cinder, and it will basically start creating the volumes. Now I'm pressing deploy this environment, the one that I've specified in the Murano catalog, and it will change to deploying mode. And in parallel, before this will end, I will be just checking in project volumes to see the steps, at which step we are at the moment. So usually I've noticed the volumes will be start to be created. First, it will be the operating system, then it will be the database, and then it will be the swap. Those will be automatically attached to an instance that's being created with a generated name, and we will then start the console, we will SSH the VM, and we'll see the entire process also inside the virtual machine, inside the instance itself. It's also a stage creating, then it's downloading. So when it's the downloading stage, it's basically using the content from the image that we are sharing during this process. Usually the process takes around 30 minutes, and I did compress it to around 9 just to have the entire process. Now you can see the second. I've made some small breaks, and then I started recording back. So now you'll see some database disk is being created and downloaded. Then you'll see the swap. Now in this stage you can see them being attached to an instance. We will go to the instance itself, and we can visualize the output. I will open. You'll see this specific instance being created by Heat. It's in running stage. I will open the console just to see the status, and all the logs from the process are being also exported in the console of the OpenStack. Well, it's not that clear from here. I will also be opening an SSH window from the control node just to identify. Can we make the screen a bit sharper? I mean, it's... Can you make the screen a bit sharper? I think it's not quite visible. Maybe like a focus from the projector side? No? Okay. I'm adding a floating IP address to just for me to SSH from the control node my my instance. Yeah, maybe just leave it. Just we only have like. No, I've just SSH. I think it's not quite visible. I could just stop it a bit. This is the important part. The SSH. Is there like a sharp
image?
Yeah, sharpness, it's 0. Maybe you can increase sharpness. Yeah, it's going a bit better. Yeah, it's a bit better. So now I'm SSHing with the key that I created from OpenStack, and I'm accessing my instance. I just want to show you that the ID matches. So this ID matches the, well, yeah. The resolution is not that great. You cannot identify the ID, but I just wanted to showcase that it's the same instance. And then we want to track, for example, PMON services, which are typically for Oracle database, which are up and running. Then I'll sudo to have root access, and then I'll identify the /u01 directory. Yeah, it's not as visible I would have imagined. So yeah, I will log in as root, and then I'll check PMON process just to see if the database is up and running. It's not the case because it's just 6 minutes have passed since the instance has started. So it will be a creation stage. It will be a configuration stage of database automatically in the background. It's not that fast. It would have been great, but it's not that fast. What it's running here, it's also in Oracle Public Cloud resources. So now it's in /u0 rack OVM. You can identify the build cluster.sh. This script is specifically used for these deployments, and it's typically used with Oracle VM server. And there is a specific log that has been generated. It's called build single1.log, and then we can trace at what stage level we are in this deployment process. I will start with tail -f just to see. Tail -f just to see the last logs being generated. A completely live session would have taken a bit more time, so that's why I decided to do the recording. And from the beginning, we can identify the SSH connection to the with using Murano agent. Then an Oracle user and the DBA group has been created automatically. Then the process of Oracle database has started here, and the creation process. I'll make some small breaks from this point, and then I'll show you that all of the rest of the processes are usually an Oracle database. It's not the easiest thing to deploy. So this basically will help you. This is almost at the end, so it just needs root access to run 2 scripts in order to give access to some Oracle database services. And lastly, we will see completed successfully in a specific time frame, and it should come right away. And it's not visible, but yeah, it's not the sharpest. Now in this it says copying database files, and then we'll continue with the configuration steps. And the percentage shown in the left side. Now we completed, and it goes to the single database installation mode. And yeah, I know it's not quite visible, but here shows completed successfully, and that specific time frame took for the deployment mechanism. And lastly, I will check the PMON process. As I said, it's a sign that the database is up and running. And you will see the change that there is a specific PMON with Oracle ORCL. And also, I will check Oracle-related processes that are running. And as you can see, there are many. So this concludes the video part. And a small summary. So, as again, why Oracle OpenStack? Well, first of all, you're benefiting from an increased operational efficiency. You will be using Docker containers for hosting your OpenStack services, and that helps a lot from the deployment process point of view to the upgradability. One of the hardest things to do in OpenStack is to upgrade from one version to another, so this simplifies a lot. And you will focus much more on the application, which are the most important aspects in an environment overall. Then it comes also with Oracle's heritage, so you have MySQL included inside. You have full compatibility with Oracle Linux, which can play the role of control nodes of storage, network. Oracle VM Server can be one choice of hypervisor. KVM from Oracle Linux is the second choice of hypervisor. We will certify it with Hyper-V as well. We had version 2, and I think it's just a matter of time until we will certify version 3.0 to go with Hyper-V. We have it before, so we will do it again. It's a partnership with Microsoft from this point of view. And yeah, it's also an enterprise class. It's free to use, free to download. You pay if you want for support. So that's all included. We released the Docker images in hub.oracle.com/oracle, and Cola packages are available in yum.oracle.com repositories. Okay, thank you very much for your attention. And questions, please. If there is time for questions, I'm not sure how we are with the time frame.
Or you can put a question after we eat something or during the networking if you want. I don't want to push it, so if you have any urgent question.
Or maybe after the
You
session.
can approach Lucian during the networking, so you decide.
Sure. Cool. Great. Thank you very much, everyone.
Thanks.